Okay. So chapter 10 is, the entire chapter is really about something called conic sections. Um, and what that refers to is if you had a cone, okay, let's say you had like a cone. Imagine like an ice cream cone. And I took that cone and I sliced it with some type of blade or knife or whatever, okay? Straight across. If I just went straight across, then what would happen is I would get a cross section here that would look like what shape? Which shape is this?
Circle.
Yeah, okay. So um, if you look at the two-dimensional shape, you would get a circle here, okay? If you were to like pan over it and look down, it would just be a circle. Now, if we had, let's say, let's draw this again. Oops. Okay. Now say I cut it on a slant. Okay. If I cut this on a slant, what would happen is it would look like, it wouldn't quite be a circle. It would be like almost like an oval shape. And we call this an ellipse. That shape, if I were to pick it out, that two-dimensional shape, and put it down, it would look something like that. Can you guys envision that? Are my drawings okay? All right. Now, the other thing is, if you cut it in a certain way, you can also get a parabola, okay? And then there's other things called hyperbolas and stuff like that. A hyperbola is just like a double parabola. Um, we're only going to talk about circles and ellipses today. So we're only going to talk about circles and ellipses. But a lot of times books will call these conic sections, but this is why. If you get this two-dimensional shape by like slicing this three-dimensional shape of a cone, okay? Isn't that exciting? Aren't you guys like so happy I told you all about that? That's all the geometry from 3D to 2D I'm going to talk about the whole course. So there it is. All right. So an ellipse, let's give you a definition. An ellipse is a stretched, we're going to start with ellipses and then I'll touch on circles. I'll circle back to the circles. Okay. So an ellipse is a stretched or elongated circle. Okay. And it has a standard form. And actually what I want to do is I just want to give you an idea. Like I can have an ellipse like this, or they can be vertical. Okay. They can be stretched horizontally, like sideways, or they can be stretched vertically on the axes. Okay. You're not going to see them tilted though. I will say that. It's not like they're going to be tilted at all. It's either horizontal or vertical. And these have a standard form to the equation. Um, which I'm going to put in blue. So I have x minus h squared over a squared plus y minus k squared over b squared equal to 1. Now let's break down the parts of this. What do you suspect h and k might refer to? Anyone brave enough to take a guess? This is not the first time we've seen h and k.
The center of the circle.
Yeah, it's the center. In a parabola, it's the vertex. It's like the middle point of the parabola. HK is also the middle point of your ellipse. So HK is the center of the ellipse. Okay, so if I were to pick that out here, that looks like the center, and this one is centered right on the origin, okay, right on 0, 0. So in this case, this would be HK, some point. I kind of lifted it up a little bit. And here is HK, but clearly this is also at 0, 0. Okay.
Do we still make H a negative or
Yeah, the same rules apply. So I'll give you some examples in a minute, H and K, when it's in this format, you just take the number. It's the opposite. But if it's plus H, then it's negative. And if it's plus K, then it's negative. Okay, but I'll go over that in just a second. The other thing I want to talk about is this A and B thing. Okay, so A and B are what we call the vertices of the ellipse. Okay, so these are the edges. So if I look here, this would be A comma 0, negative A comma 0. I don't know, maybe it's 2 and negative 2. The point is it's the same distance left and right away from the center. Okay, A measures the distance from the center left and right. And then up and down, this is going to be 0 comma B, and then 0 comma negative B. B measures the vertical. So I'm going to write that out in detail here because I want you to have it in your notes. So A tells the number of units from the center, the ellipse is stretched horizontally. In other words, left, right. Okay. And then B tells the number of units from the center, the ellipse is stretched vertically. In other words, up, down. Any questions? All right, I'm going to put an example. Example 1. Let's graph x squared over 4 plus y squared over 9 equal to 1. Okay. Now, what do you think, looking at this, my center is going to be? Any guesses?
1, 1 or 0, 0?
Yeah, that's pretty good. 1, 1 or 0, 0. Okay, let's go with 0, 0. And let me show you why we can say that. Because this isn't technically exactly in the format, but it would take like 2 seconds to write it that way. We could just write, instead of x squared, that's the same as x minus 0 squared. And y minus 0 squared over 4 and over 9 is equal to 1. Okay. There it is. Okay. H and K are 0, 0. Now, if I were to subtract 1 and 1, it would be different. But by putting that minus 0, it is literally the same as what I just had. Okay, that's cool, right? Everybody good with that? The other thing I want you to notice is in an ellipse, it has to be equal to 1. Okay, in order for something to be an ellipse, you must have 1 on one side of the equation, on one side of the equation. Okay, you really can't tell unless you have this, because that's what it means to be in standard form. Just like y equals mx plus b, I didn't say 2y equals mx plus b. I mean, y has to equal mx plus b. And just like in the, when we do parabolas, that's a very rigid form. So it's very important that we have 1 on a side that tells you that it is an ellipse of some kind, okay? To be an ellipse. Okay, now the other information I get from this is these numbers here, okay? So A, now remember, that number underneath is actually a squared. I don't want a squared, I want a. So a is going to be the square root of 4, which is 2. And b is going to be the square root of 9, which is 3. So these go with that. Any questions there? So I need this information in order to graph. Once I have this, graphing is easy peasy, okay? So let's do that. All right. So here's x, y, and my center is at 0, 0. So I'm going to put that on there. There's my center. Now, to get these to look good, you do have to take extra care that your units are pretty evenly spaced. Otherwise, they look lumpy or off. I mean, do the best you can, but all right. Now, from the center, that A tells me left and right, the number of units. So this is left, right from the center. So that's here and here. And then B is up, down. So I'm going to go up 1, 2, 3, and down 1, 2, 3. And these are called the vertices. And you see they kind of look like vertices now, the way we have them written. And I want to label all the points. It's also important that you label your points somehow. So this is 0, 3. This is 0, -3. And then I have 0, 2, 0. And then -2, 0. And then the last step is to draw the ellipse. And you're going to draw it through your vertices. And it's rounded. Just do the best you can. Okay, so this side's a little off. All right, as good as it's going to get. And there's my ellipse. Any questions? You guys loving this geometry? It's a little break from stuff, a little bit. Relates, but it is different. All right. No questions. You guys are good? Let's look at this example. Let's graph. Okay. X plus 2 squared over 16 plus y plus 5 squared over 1 equals 1. So I put this over 1, but you guys, you understand that if it were just like this, that's the same. You can put 1 over under anything, right? Okay. All right, so let's look at the center here. Let me call on somebody. How about Mihaly? Can you hear me? What do you think the center is here? Are you there? He did say he's having computer problems. Okay, how about Andrew? What's the center?
Wouldn't it again be either 0, 0 or 1, 1, 1?
Nope. The center is gonna be pulled from these numbers here. Okay, that tells you the center. Just
2
like,
and 5.
what is it?
2 and 5.
Yeah, except just like in the parabolas, how it's opposite here too. So it's going to be -2, -5. Okay, it's the same concept. The standard form is in minus. Okay, standard form is minus. So when it's minus, you just pick the numbers h and k right out. Okay, but if it's plus, then that means it's really minus a negative. So it's going to be opposite. Is that cool? Everybody, is that clear enough? All right. Now for the A. How about Ariana? See, I remembered. Are you with me, Ariana?
Yeah.
Okay, what would you say A is?
Would it be 2 or -2?
Okay, are you looking at where I have it highlighted?
Yeah.
Okay, remember A is coming from underneath the X term.
Oh, okay.
And this is coming from underneath the Y term. So 16 is A squared. So then what would A be?
4.
Beautiful, very good. So it's going to be the square root of what's underneath the X value. And then B, it's the same deal. Square root of 1 is 1. Okay, thank you. Very good, Ariana. Okay, so once we have this information, that's all we need to graph this. Like we're ready to go, but you have to be able to read that from the equation first. So let's see here. My center is -2, -5. So let me put some equal little grid. I wish this, I wonder if there's a way, I wish it automatically gave me a grid, like not just the axes. I wish I could just like make a grid the same way. That'd be really nice. Maybe I'll email them and tell them to upgrade it to that for me. All right, -2, -5. So here's my center, -2, 1, 2, 3, 4, 5. It's like right here. Okay, now you have to count away from the center when you're doing A and B. So A is going to be left, right. So I'm going to go left, right, 4 units. So here's 1, 2, 3, 4 units right. And I'm going to add on, the quick way to do it is add on to the X value. So -2 plus 4 is 2. But you can see that it's underneath the 2, right? And then I'm going to go 4 units the other way. So here's -3, 1, 2, 3, 4. And that's going to be 1, 2, 3, 4, 5, 6. So this is -6, -5. Any questions about how I did that? So you're going 4 units away in both directions. And you can see it's not, my drawing is a little off. So in fact, this one I can move over 1, 2, 3, 4, 5. This is not, I didn't make my hash marks perfectly even. So, oh well. It doesn't have to be perfect. All right, and then B is up and down 1. So I'm only going to go up 1 and down 1. So this is a really skinny ellipse and it's horizontally stretched. Once I have my vertices, then I'm going to draw my ellipse. Okay. And the ones above and below, that's going to be -2, -4, and then -2, -6.
We always have to label them.
You should.
All right.
Should get in the habit of doing that, yes. Any questions? All right. Example 3. Graph x minus 3 over 9, this is squared on top, plus y squared over 9 is equal to 1. So we should notice that first of all, it's equal to 1. So it is definitely in the ellipse. I have a plus in the middle. That's good. I didn't mention that earlier, but the plus is important. You have, if it's a minus, it's something different. Okay. It's actually a hyperbola. So it has to be plus in the middle. But since we're not doing hyperbolas, I'm never going to give that to you. But just FYI, and you can say she said it one time, a long time ago. All right, so let's look at the information here. What would you say the center is? How about Layla? What's my center?
3, 3, 0.
Yes, beautiful. Good job. 3, 0. And then my A and B. How about Lydia? What would you say A and B are here?
Wouldn't it be 3 squared and 3 squared?
Yeah, this is 3 squared and 3 squared, but I want just A, not A squared. So A is A 3 squared or is A 3? I guess that's what
3.
I'm asking. It's 3, yeah.
3 and 3.
Yeah, okay, good. All right, so now that's it. That's all we need to know. We can graph. Seems kind of boring, but let's see. Let me try to do a good job of being equal here. 1, 2, 3, 4, 5, 6, 7, 2, 3. All right, I did okay. So let's see how this goes. All right, my center is 3, 0. So that's right there. And then I'm going to go equidistant, or I got to go both 3 units away, left and right. So 1, 2, 3. 1, 2, 3. There's my horizontal vertices. And then my vertical vertices here are here. So if I label everything, like I just said we should, this is 6, 0, 0, 0. If I go up, it's 3, 3, and down is 3, -3. Those are a little easier. Now, we got to draw the ellipse through our vertices. Yeah. All right. Here's a question. What's special about this ellipse?
It's not,
Anybody see it?
not stretched.
What is it?
Not stretched.
It's not what? Stretched?
I believe
Yes,
it.
that's correct. It's not stretched. It's not stretched at all, is it? If my distance left and right is the same as the distance up and down. So every point on this circle is going to be, if I pick any point, its distance from the center is the same in every direction. Everybody see that? That, my friends, has a very special name. What kind of shape is this really?
Circle.
It's a circle, okay? So here's an observation. When A and B are the same, the ellipse is a circle. Okay, so just like in a rectangle, when the sides are all the same, what do we call it?
Square.
The square. Okay, so in an ellipse, when the A and B, or the vertical and the horizontal, are the same distance, that's a circle. Okay, so this is it's really a circle. So let's say a few words about circles here for a minute. All right. Definition. Here's a definition of a circle. So really 10.1 in your book is circle and 10.2 is ellipse, but they're so similar. That's why I kind of teach them together. So a circle is a set of points in a plane that a set that is, I think my English on this has been wrong for a long time. Set of points in a plane that a set is a fixed distance, which we call R, which stands for radius, from its center, H comma K. Okay. So the standard form of a circle, it's a slight variation of the ellipse form. Okay, because now I don't really need A and B because they're the same. So we say the standard form, it's still x minus h squared and y minus k squared. That part doesn't change. It's still a plus in the middle and it's still equal to 1. But instead of writing a squared and b squared, we recognize they're the same and it's just the radius. So we call that r squared and r squared, right? It's the same number. Now, or equivalently, this is another way you'll see a circle. If I were to clear that fraction, say I multiplied everything by r squared, okay, then this would be x minus h squared plus y minus k squared equal to r squared. So these are both more indicative of a circle than an ellipse, a special ellipse that is a circle. Any questions on that? Comments, concerns? All right. If you're with me, give me a thumbs up so I can see. And I know you're not just like watching YouTube videos or sleeping. Okay. All right. Thank you guys. All right. So now we're going to play a little game. It's going to be interactive. So I want to classify the following as either ellipses or circles, which, to be fair, they're technically all ellipses because a circle is a special ellipse, but I want to know if it's that circle or not. Okay. And we're going to state the center. And radius or A and B. Okay. And here's what I want you guys to do. I think this would be easiest. It worked really well with my last class. If it is a ellipse, use the reaction of thumbs up for me. And if it's a circle and you're just going to guess, and guess what? You get a 50-50 chance of getting it right. So why not just play? Okay. It doesn't matter if you're right or wrong. Just take a guess. And then the circle is going to be the laughing face, because it's kind of circular. Okay. So here we go. Equation and then classification. So here's A. Ready? X minus 1 squared over 4 plus y plus 2 squared over 9 is equal to 1. So if you think this is an ellipse, give me a thumbs up. If you think it's a circle, give me a laughing face. All right, lots of thumbs up. Got a laughing face. Okay, almost. This is very good participation, you guys. Great job. Okay, so yes, you are right. This is an ellipse. Okay, how can we tell for sure? Well, we've got the 1 and we've got a squared and b squared, and they're different. So it can't be a circle. So this is an ellipse. Let's state the center. How about, let's pick Micah. What would you say the center of this ellipse is?
Center would be think
Which two numbers do you think you got to look at?
4 and 9.
Ah, those are the A and B's. It's always what's adding and subtracting from X and Y.
Oh, okay. So it would be -1 and 2.
Almost. Just like in the parabolas, it's opposite. Okay, so the minus is the standard form, so it's just 1. We're just going to take the 1. And then the plus 2 means it's -2. Okay, so it's the same kind of concept. Now, A is going to be the square root of 4, which is 2. Excuse me. And B is square root of 9, which is 3. Okay, any questions on that from anyone? Ooh, this is good. Okay. All right, second one, right, guys, ready? Circle or ellipse. X squared over 4 plus y squared over 4 is equal to 1. All right, if you think it's an ellipse, give me a thumbs up. If you think it's a circle, laughing face. Oh. Everybody, you guys, I tell the best jokes, like you're all laughing at me. Just kidding. I'm so stupid. I'm sorry. I'm sorry, you guys, but it's a, you know, working from home. All right, so you are correct. This is a circle. It is a circle. And let's get the center here. How about Rodney? Are you there, Rodney? Paging Rodney. What is my center here? What do you think?
Would it be 0, 0?
Yeah, good. Very good. And then in this case, since it's a circle, I don't have A and B, I have a radius, which is going to be square root of 4, which is 2. Okay, my radius is 2. Any questions there? All right, nice job. But I will try to fool you. Keep you on your toes. Okay, so x minus 2 squared over 10, I'm sorry, x minus 10 squared over 10 plus y plus 1 squared over 7 is equal to 1. All right, so here we go. Thumbs up if it's an ellipse, laughing face if you think it's a circle. Okay, I'm getting mostly ellipses, but a little bit slower. Okay. All right, you are correct. This is an ellipse. And everything's in the right form. And the only thing that's different to make sure it's not a circle is that the denominators are different. That's the way you can tell the difference in this one. So let's get the center. How about Angelica? What would you say the center is?
10, -1.
Good job. 10, -1. And then A. Do you want to take a shot at that? What do you think A would be? It's a trickier
The
question.
square root of 10, but I can't figure that out right now.
Yes, you're correct. And similarly, B is going to be square root of 7. Okay, so here's the thing. everything I've given you so far has been a perfect square because that is much easier to graph, okay? But they don't have to be perfect squares. That is just, when you look at how to find A, you just take the square root of what's in the denominator. So if I were to graph this, I would just have to count out square root of 10 units and probably do more like an approximation, okay? But we're not gonna graph this one. All right, here we go. X squared plus y minus 8 squared is equal to 25. If you think it's an ellipse, give me a thumbs up. If you think it's a circle, laughing face. Some people are trying to figure it out. They're thinking. Okay, about half of you say circle, and I'm assuming the other half are not sure. Okay, so the first thing is you should notice is this is not equal to 1 and I have no denominators, right? Thank you, Micah. I like that. Now, we could get this equal to 1 very easily. I could just divide everything by 25. What's 25 divided by 25? It's just 1, right? It's just 1. So you can see that this is x squared over 25 plus y minus 8 squared over 25 equal to 1. These are the same. This is what I was talking about earlier. Now you have A and B are the same. You should see that clearly it's going to be a circle, right? Circle. So this is a circle. And my center, how about, let's see, find someone I don't ever call on. How about Joe? You with me, Joe? What would you say the center of this circle is? Joseph?
I'm not entirely sure.
Okay, good. That's a good answer. What would you say is being subtracted from x in this problem?
0.
0. So that's your x coordinate of your center. What about the y?
8.
8. So that's it. My center is
okay.
0, 8. Okay.
All right.
You just, it's in the right format. You can just pick it off. Now my radius is going to be square root of 25, which is 5. Okay. Any questions from anyone on that? All right, here we go. E, 4 times x minus 2 squared plus 25 times y plus 2 squared equals 100. Now, this one's a little bit of a thinker, but it's still fun to guess. So what do you think? Thumbs up, ellipse, happy face, laughing face, circle. Or okay, Joanne's brave. She says ellipse. Charday Albana ellipse. I've got a few circles. So this one's more mixed, right? We're not really sure. Good. Nice participation. Abir, are you there? You're not, did you guess?
Oh, my bad.
What is this, Abir? Is this an ellipse or a circle? Now I'm gonna call you out.
Looking at this, I think it's an ellipse.
Okay. All right. So we're not sure because it's not quite in the right format, right? Remember what I told you, ellipse has to have a 1 on a side of the equal sign. Well, we can get that. Let's divide everything by 100. Okay. It's just one simple move. That's going to give us equal to 1. The only thing is we're going to have to simplify. What's 4 100ths and what's 25 100ths? These both simplify. Okay. This is 1 over 25. And this one is 1/4, right? So these fractions, 4 over 100 becomes x minus 2 squared over 25 plus y plus 2 squared over 4 Just make sure I didn't screw that up. And then equal to 1. So just because it's not exactly an ellipse form, we can get it there fairly easily, okay? Any questions? So this, everybody who said ellipse, you were correct, okay? All right, what's my center here? How about Hassan? What's my center?
Would it be 2, -2?
Very good. And then A and B, A is,
Would it be 5 and 2?
yes. Okay, good. All right, last one like this, and then I'm going to show you something else. Let's say we have 2 times x plus 4 squared plus 2 times y minus 2 squared. Let's say plus equal to 1. What do you guys think? All right, let's do my quickly thumbs up if it's an ellipse, circle, if happy face, laughing face. Oh, we got some division in the ranks. It's pretty evenly divided. Wow. Okay, so, oh, you know what? I screwed up. My fault. This should be a 36. So if I had time, I would ask you to redo your answers, but we don't have time. So again, since the problem is I have these 2's here and I didn't give you anything, we don't want to keep those 2's there. So let's divide everything by 36 to get that 1. And this will be 1, right? So that's 36 divided by 36. I don't want to have to write it again. So 2 over 36 is really 1 over 18. So if I simplify, I get x plus 2 squared over 18 plus y plus 2 squared over 18 equal to 1. And your center is -2, -2. Which kind of shape is this now? It's definitely a circle. I can tell because these numbers are the same. Okay, when it's the same. So my radius is square root of 18, which does simplify to 3 root 2. Okay, any questions on that? Okay, so this gives you guys a little bit of experience and how to figure out if it's an ellipse or a circle. A little bit of experience how to get it in the right form. But now we're gonna go all out, because here's if we were doing these for real, you're never really given equations in the perfect form. This would be what you get. X squared minus 4x plus 4y squared plus 8y minus 8 equal to 0. Circle or ellipse, what do you guys think? Who knows, right? We don't know. This is not anything like what the standard form looks like. So what we're going to do this, to get this in standard form, we need to complete the square twice. Yes, if the denominator is the same, it's always equal to a circle. That's right, Layla. We need to complete the square 2 times. Okay, so if you notice, the standard form has something squared and something squared. How do I get that? I complete the square. So I'm going to have to complete it for the x terms and for the y terms. All right, so we're going to do it simultaneously. So here's x squared minus 4x. I'm going to group those together. And then I'm going to group the 4y squared plus 8y. And then I'm still going to leave that number off to the side. That number doesn't get included in the x's or the y's. Okay, so the first step is still grouping. All right. Now looking at this first one, I have a 1 in front of the x squared. So we can go ahead and do our thing here. So I'm going to take my middle term, -4. I'm going to divide by 2, and I'm going to square it. So this is -2 squared, which is 4. So I'm going to add 4 minus 4, just like we did with the parabolas. Any questions on that? Now, for the y term, I have a little bit of trouble here because I can't have that 4 there. So I'm just going to bring this down. And I like my color scheme here. I'm going to keep it going. And I'm going to factor out this 4. Okay, because remember, you have to have a 1 in front of that square term. Coefficient 1. Now we'll do the same thing. I'm going to use the 2. 2 divided by 2 squared is 1 squared, which is 1. So we're going to add the 1 minus the 1. Any questions there? Okay. Now let's kick stuff out. Okay, so I'm going to kick out the minus terms. So this is going to be x squared minus 4x plus 4 plus 4 times y squared plus 2y plus 1. Now when I kick out the -1, you have to remember that it's being multiplied by the 4. So it's going to be -1 times 4. Oh, I forgot to write my -4. -4, and then I have -8 is 0. Okay, so just to be clear, here's from the x term. This one is from the y term, and then the -8 was there all along. Any questions? All right. All right, now the whole purpose of this was to get something squared. So this is x minus 2 squared plus 4 times y plus 1 squared. And this is going to be -16 is 0. So we're not quite there yet, but we're closer. You can start to see that the standard form is emerging. Okay, so let's add 16 to both sides. So I get x minus 2 squared plus 4 times y plus 1 squared, and this is equal to 16. Now I still need a 1, so let's divide everything by 16. And I am hurrying a little bit here because I'm almost out of time. So this is now 4/16. You have to simplify this. Don't forget, this is 1 plus y squared over 4 and equal to 1. And now I have it in the ellipse format. And this is clearly an ellipse because my denominators are different. So my center is 2, -1, A is 4, and B is 2. So my goal here was to graph it. So let's do that real quick. So 1, 2, -1. Here's my center. I'm going to go 1, 2, 3, 4 units, right and left. 1, 2, 3, 4, which is -2, -1. And this is going to be 6, -1. And then up and down, 1, 2, which is 2, 1. And then down 2, which is 2, -3. So here's my ellipse. Okay, questions. So sometimes you have to do just a little bit of work, like divide by something. Sometimes you're lucky and it's just given to you. And then other times you have to do quite a bit of work to get the right form. Okay. All right, you guys. Tonight is hand-in homework due tomorrow. And then tomorrow is online homework on this stuff. All right. I will see you tomorrow. Have a great day.